This is Technology for Humans, conversations with the people shaping the software we rely on, produced by Reinteractive, a Ruby on Rails development agency. We speak to CTOs, founders, and engineering leaders on what they're building today and how they're thinking about what comes next. I hope you enjoy the podcast. Hello, everyone, and welcome to the podcast. And I am absolutely honoured today to be speaking with José Valim. José, I know I've said your name incorrectly, so feel free to correct me, but I just want to say a few things about you before you do that. You are one of the more, you have quite a list of credentials. So you're currently the Chief Adoption Officer at your business, Dashbit, which I'm going to ask you about in a minute because that intrigues me. You used to be a contributor to Ruby Core, which is of enormous interest, and you are the current developer of the Elixir language. Is all of that correct?
Yeah, contributor to Rails.
To Rails,
everything else is correct.
Excuse me. Okay. All right, and then how do I pronounce your name correctly? Because I want to have that on record.
Yeah, it's José Valim, but don't sweat about it.
Okay. So you're originally from Sao Paulo, is that right?
So that's kind of I kind of moved around a lot. I mean, now I'm stable. But going back, I was born in the south of Brazil, in Porto Alegre. But I was literally just born there. My parents were organizing an event. I decided to come up early, and then so through all made a mess of all the plans they had. But then my first 7-8 years was in São Paulo. Then I grew up in the center in a small town close to the capital of Brazil. Then university, I went back to São Paulo. Then I did my master's in Italy. And right now I live in Poland. So, because my wife's Polish, we have kids, half Brazilian, half Polish. And that's kind of and I've been living in the same place now for 15 years. But before those 15 years, it was kind of I was never in the same place for more than 3 or 4 years, I think.
Now, Poland has an incredible developer community, doesn't it?
It does. Yeah. And I'm in Krakow in particular, which is where I live, it's very active. And there are a lot of some of the best computer science universities in the country are here in Krakow. So it's a really nice place to be.
But the Polish developers reach out across the planet and influence all sorts of things. They're quite influential.
Yes.
How's your Polish?
So I speak at home we have this interesting dynamics because I speak to my kids in Portuguese, I speak to my wife in Polish, and my wife speaks to the kids in Polish. So before I had kids, my wife and I would just speak in English. And because I was always working remotely and most of my work is in English anyway, I didn't have a lot of opportunity to learn Polish. So after we had kids, then I started picking Polish much more. And I find things not the grammar, the pronunciation should be quite straightforward. It's not like English that, if you look at a word and they're how do I pronounce it? You don't know. You need to have somebody pronouncing it before.
It's not always obvious.
But Polish is like Portuguese in the sense that, you can look at a word and you okay, I know how to pronounce it. So at least that part is easy. But grammatically, it has a lot of complexities. So, for example, the one that I the example that I like to give is in terms of counting. So, Portuguese and English, we have singular and plural, right? So 1 chair, 2 chairs, right?
Yeah.
That's it.
Right. Easy.
And Polish and a lot of the Slavic languages, they have singular few and plural.
Okay.
So they added like one more thing for you like to consider, for you to take into account. There's like this extra thing. And it's interesting because like 1 is singular, 2, 3, and 4 is few, and then above that is plural.
It's more than a few.
That like 22, 23, 24 also you have to use few as well when you are like,
okay,
right? Like, and then 32, 33, 34. So it goes like, so we're like, oh, okay. So, if it ends with 2, 3, and 4, then I guess it's few. But notice that I skipped 12, 13, and 14. Those do not go with few. So like if you use an internationalization library, like we have in Ruby, like we have in Elixir, at some place they have to put all the internationalization, like all the pluralization rules. And actually, like the Polish one in terms of lines of code and the other Slavic languages are the ones that require the most lines of code for you to express how to pluralize. So I have like kind of like an actual metric. Like if I put this into code, I can show it's more complex.
Yeah.
And the funny thing is, like, if I go talk to my wife about this, she doesn't think about this, right? It's in her head.
Of course,
that's why it's the
natural.
joke. Yeah, that's the joke. Like you have like it's like like life's too short to learn it, because for them it's like they don't think about it. And then later on, I realized the reason why they skip, I think, I haven't checked if this is actually true, but the reason why they skip 12, 13, and 14 is actually because in the same reason that in English, we say 12, we don't say 10-2, 10-3, right? Because we say 22.
Right. They're completely different words. Yeah.
Yeah, so it's probably related to that, but it's not something like I had to. Someday I was like, oh, it dawned on me, like, oh, that's probably why. But nobody explained that to me. Like, oh, you can use this trick.
You just got to figure that out.
Yeah.
That sounds almost as complex as trying to figure out how to represent correct dates in any programming language. Trying to figure out time zones and, all of that sort of stuff and the significances that we have to put on that sort of thing.
Yeah.
Let me ask you about what a chief adoption officer does, because I haven't heard this term before and I feel like you've probably made it up for something very specific.
Yeah, so it's really about so I'll tell a little bit about Dash a bit, and I think it's all going to make sense. So, so Elixir, when I started working on Elixir, I worked at a company called Plataforma Tech. And we were quite known in the Ruby community because projects like Devise, Simple Form came from Plataforma Tech. At some point, we had 3 members of the Rails core team at the company, which was Carlos, Rafael, and myself. So we were quite known in the community. And then later on, I started working on Elixir. And one of the things is that, so this was like 2011, 2012. And like creating a programming language, it's like when I started working on the project and it became sort of like a company project, I told them like, look, I can work on this for like 3 years, 3 years, and nothing may come out of this. Like nobody uses it. And then it's just a project that we tried and then we have to retire it. So, and to the point that I think like, I started working in 2012, and then our first client was only in 2016. So it was a good amount of development for us to have our first client, not to recoup the investment that we did. And during quite some time, I was the only person who was working like at an official capacity. Of course, other people at the company contributed, but the one who are like, well, you are being paid to do that, right? Either at the beginning part-time and then full-time, it was only me. So for me, I always had this question, which is the sustainability question. It's like, well, as the language starts to grow, how can we have more people working on the language and on the ecosystem and be funded by the company? And it's fundamentally like an adoption and sustainability problem, right? Because in order to do that, we need to have more companies adopting Elixir so we can get the knowledge, can get our services and invest that. And then we started this as a product at the previous company, Plataforma Tech. And then that company was acquired by another company. So Plataforma Tech no longer exists. And then I came out with Dashbit, which is exactly, well, we want to be, so we are a small team. We are about 5, 6 in our team. And our goal is to marry those things that I was talking about, like the sustainability of the Elixir ecosystem. So we want to be continuing investing in the language, in the ecosystem, and then work with clients and collect feedback and how improve things and use what we learn and use the resources that we got from working with clients. So
you're not a traditional development agency.
It's so that's the thing. I wouldn't class, like, it's kind of what we do is I wouldn't say it's a development agency. So the service, we have one service, which is the one that we see on the website, which we call is the Elixir development subscription. And it's basically a contact direct line from your engineering team to our engineering team. So we are not actually doing development. It's more of like it's a mix of consultancy with development, because our goal is also not to be like, hey, so we also did a lot of that before, where at the beginning, what we would do is that so this is like almost a decade ago, when we started having the first Elixir clients, what would happen is that they would say, hey, we built this application. We want you to look into it and give us feedback. So we would go through all the code, have meetings with them, right? Figure out if there was a part that we're struggling with, help them do that. So it was like a 1-week engagement. And then we would like deliver a report, like 1 week, 2 weeks engagement. We would deliver a report. And then they're like, fantastic, right? Like, we paid, this is good, right? That's kind of like what some consultancies do, right? And then what would happen is that 3 months later, they would say, hey, we finally have the time to look at some things that were in your report, and we have some questions, right? But at that point, we already, like, it was 3 months has passed. We didn't have like the full context of the project anymore, or we would be in another project and we did not, like, they would have to wait until we could come back and focus on that. So we were like, well, like, what if what we do is sort of like a ongoing relationship? So that's why I would say it's like development subscription, because we work with a limited amount of clients, so we can always have their context in our head, because we do not have like the churn of changing clients. It's a new client every month or every 2 weeks.
Oh, of course. Yeah.
Right. And then whenever they need anything,
it helps with the whole cash flow as well. Like, where the next dollar's coming.
Yes, it gives a lot of stability to the company. We don't have to be like, oh, we need to have a sales team bringing the next consultancy project, right? So, and we always have their context. It's also great for the client because they don't have to onboard consultants, like onboard us to the project. We onboard once, and we are working with them, and then we are working. So, like, in our day-to-day, we are reviewing pull requests. So they send a pull request, we drop feedback and where they can improve, pitfalls they can avoid. We can jump into meetings. So it's a very, I think in certain ways, a very unique proposition where, like, look, we're not doing development work, but we're working closely together in a stable relationship and long-term. And we use that to the benefit of the community, right?
Right. And so you take the feedback and develop features or bugs or whatever.
Yes.
Yeah.
Yeah. So some of our open source projects that we released was because we saw like 2 or 3 different clients implementing the same thing. And then we would always we would see the pitfalls, like, hey, like, people are always running to this thing, or like there's this common thing, and they were like, okay, we are planning to create a common abstraction. Can we go ahead with that? So one of our projects called Broadway came exactly from that, from looking people building similar abstractions, and it was like, oh, we can create one that everybody can use. Yeah, and also like and the title in particular. So this is to give all the context, right? So our goal is to help Elixir adoption, both inside the company, but of the ecosystem in general, of the language in general. Platform Attack at some point, I think we were between like 70 and 80 people. It's not a big company, but
yeah,
it is like,
that's fairly fair size. Yeah. Yeah.
Yes. Right. And for these, we're like, look, we don't want to go the direction of a big company. We want to stay small, work with a small number of clients. Like, this is not a business that I want to scale. And for me, it feels weird to say like I am the CEO of a six,
because it's a smaller team. Yeah,
right? Like it's a 6-person company.
It no, I think you got to be like 10 or 15 to warrant that title. I think maybe.
Yeah, and then it's like it's also not also a product. So like founder of a small team. So I was like, well, I need to come up with something that is going to kind of reflect what I do, but not really, but also be interesting and not be kind of like over, like not self-aggrandizing in the sense, like, like saying CEO of like a team of 3, right? So
exactly.
That's where the adoption came, because I think it puts like my main responsibility, right? And what we are helping our clients with and how we are helping the community in a single word.
So there's obviously some sales involved, but there's a PR aspect and a public outreach and a community aspect.
Yes, and a lot of it. So that's interesting, because I think like when you talk adoption, then you can. There are so many things you can do about adoption, right? And I think like that's the can be like one of the potential, let's say, downsides in like I cannot have a better word of like with the chief adoption officer, because people think like, well, now I should be responsible for all the adoption aspects of the community. But I think that's actually impossible, right? Like, I think if you have one person or a company that is responsible for all the adoption aspects of the community, then it's probably not a healthy community, right? So you need to diversify that as well, right? So the adoption, in the sense, we can talk about this. You said that's one of the parts that you were interested in hearing, because for Elixir, like when it comes to adoption, I mostly try like in general, when everything comes to Elixir, I like to say I try a decentralized approach. I feel like everybody, if you want to organize an event, if you want to write a book, if you want to do an open source project, like nobody needs to ask me permission for anything, right? Because
just get it done.
Yes, like of course, like we always trying to find ways to help, right? But the goal is to allow everybody to be or make the change they want, right? And then when I'm thinking about adoption, is like, well, I'm thinking as like the person who, mostly like the company who is guiding the language, right? And the language future, because that's a part like, like there are things that you want to make that are open to everybody, right? But when it comes like to technically the language, right, you need to have a group of people, which is the Elixir core team, that are the people responsible for making those decisions, right? In the same way that if you decide to, create like the Elixir Conf Australia conference, right, then that becomes your responsibility and the thing that you own, right?
Yeah. Which makes sense. And I think that's a great way to do it, because it's inclusive. It's saying to people, do what, you're encouraged to do those activities, to create the community wherever you are.
Yeah.
a lot of people probably don't realize, even when you look at something like Rails or Ruby, if you want to help, just put up your hand and this is what I want to do, and off you go. Okay, like if you wanted to be part of the Ruby committee, and you had concerns about the direction the Ruby Central was going, you want to be part of the Ruby committee, just jump on board. It's going to be that easy. Like, just send them an email, and you'll be there. You'll be contributing. You want to. I had an idea about something I wanted to do with some small events to encourage new people into Rails locally in Australia. And I thought, this is a great idea. I sent an email to the Rails Foundation just because I felt like letting them know, actually. And the response back was, great. Let's look at getting you a grant to do that.
Fantastic.
And I didn't accept it because I can't. The money should be flowing the other way. But it's that easy to just start. You got an idea, just do it. And I'm sure it's the same for Elixir. If you want to do a meetup, just do a meetup.
Yeah, definitely. Like, like my main job is like to not get in the way, right? I definitely don't want, because when you start centralizing, then you start having like all those decisions going through like this bottleneck, and it's going to get in the way of things.
Yeah, definitely. What sort of ideas, like when you sit down, you sit back and you go, okay, I've got this incredible language, solves a problem. I'm going to ask you about that in a second because I'm interested, but it solves a problem. More people need to know about it. What would you encourage people to do to get more involvement? Like, what would you like to see happen? Just, ideas.
In which sense? It's
to get. I think really the question is about to get junior developers in, because if I was a computer science student and I was at college or university and I said, okay, I'm going to study computer science, what am I going to learn? I'm going to learn Python just every day of the week. That's what I'm going to learn. I'm not going to find out, I might hear about Elixir, I might hear about Rails, I might, but I'm going to be learning Python probably.
Right.
So how do we change that? What do we do about that?
Yeah, I think we like, and I mean like Elixir, Ruby, and everybody else except JavaScript and Python. We probably need to accept that we are going to be the second languages. I think it's very hard for us, for any other language except those two, to claim to be like, oh, we are going to be the first language. And this is because like I was talking to some friends some colleagues who own like a big learning platform, and they were saying like they were showing me the data, and like the huge majority, and this was before AI, because I don't know what is going to happen now, is like they're like 70 or 80% of the people, they were learning on their phones, which for me it's like, what? Right? Like how, right? Exactly, right? They're like, people are learning from their phones, so you need, and if you're learning on the phone, right? How, like, what are really like the things that they can build, for example, are web pages, and that's all right, and that like already funnels a lot of them to JavaScript, and having the experience, right, of what you can build is something that you can run in the browser, right? So, like, taking your question literally, I think like the most wise plan is like, well, we need to focus on the second language, and then there are a lot of different ways that we can approach it. Like, so one of the ways could be like just from like we can approach from like intellectual curiosity point of view, which is, if you learn Elixir, for example, it is going to change the way you think about software, right? Okay. It's going to it's going to change how you think about failures. It's going to change how you think about data and how you organize your programs, which, regardless of, if you are a junior, if you're an advanced developer, bringing those new perspectives is going to, even if you say, look, I learned it for 6 months, I am moving on, it's going to bring like fresh ideas and fresh perspectives that is going to kind of like enrich the way you think, right? The other way is like, well, if you want to have a tool that is going to make you productive in a bunch of different domains, Elixir is also going to be suitable for that, because for the last decade, really, a lot of the systems that we have been building, more than the last decade, are systems that are collaborative and they are real time, right? Those are systems where information is coming before. I mean, we still build the applications, right? Where it's like, well, I can go and I reload the page and then I get the information. It's like, it's a very pool based approach, right? But most and Elixir is going to be great for that, right? But most of the applications that people build today, I like to say, like, they have push aspects to them, right? They have parts where you're not waiting for the information arrives to your screen,
okay,
right? And that has happened, like, I like to say, like, since when the iPhone launched is when we started having that, because we start like getting
it's a change in paradigm.
Data on our phone. Yeah, it completely changed the dynamics, right? And it led to a bunch of interesting problems, because before, for example, like, if you were a big company, like, and you had to deal with traffic, right? You usually know, like, when you look at the access patterns, you usually, like, day after day, it was kind of similar. Like, you would have like like, oh, at this time you're going to have the peak. You would know, like, the user base. But when this flow changed, when it started being pushed, it means that now, so for example, something big happened, people get a notification on their phone, and then everybody immediately would go to the internet and get more information about it.
Right.
So it completely do a chaos of, like, well, now you need to prepare to the biggest spike of your life. At any moment, it can happen.
You got to be ready.
Yes. So it changed the operational side of things for a lot of companies, but also changes how they have to architect the software. Right? Well, if you want to push data, if you want to have, like, this conversation ongoing, and, like, you have, like, the software needs to be ready to do that. And the interesting thing about Elixir is that it builds on top of the Erlang virtual machine. And the Erlang virtual machine was created by Ericsson, which is a telecommunication company.
Oh, okay. Ericsson,
and if you think about it, like, telecommunication is literally like sending data around, sending data and receiving data at any time.
Yeah.
Right? And the web is exactly that. Like, you have a server, you're sending data to phones or receiving data from phones. For some reason, you're sending and receiving data from fridges, because now we have Internet of Things, right? So, like, the whole platform was designed for that, right? So it's like, it's the perfect platform to do anything on the web, really. And potentially, like, the largest application running on the web today is WhatsApp. And, like, they have more than 1 billion users, right? It's like, it just operates at, like, this massive scale, and they're built on their Erlang virtual machine as well. Right. So for me, it's like, it has all the abstractions to make building those sort of programs really straightforward, productive, and feel nice. But also, it's going to grow, right? Like, it's going to scale from 0 to, like, literally billion people scale. Yeah.
What was the primary problem you were trying to solve that you couldn't solve in Rails?
Right. So the primary problem was concurrency. So, like, this was back in 2006, 2007. So that was when I started hearing, like, that's when we started to get machines with 2 cores, right? Like, so we started having, like, the dual core machines.
What Rails number were we on? What?
No, this was Rails 2.
Yeah, okay.
Maybe, no, it was after Rails 1. Yeah, it was Rails 2.
Okay.
Between Rails 2 and Rails 3. So that's when we started having those discussions, like, of concurrency, right? And like, dual core, and then we started having quad core. And today is like you have a wristwatch, and your wristwatch has 4 cores, right?
Yeah. Easy.
So
yeah.
And so we started having those things, and I started running into things that were kind of like signaling me that something was missing. I did not know at the time. So, for example, I think around Rails 2.1 or 2.2, it was announced that Rails was thread safe. Okay, so let me give a bit of context here. So, if you have a machine with 4 cores, for example, and if you want to use all the cores on that machine, the way that programming languages usually solve this is that they have this thing called threads. So you can start like multiple threads, and then those threads, they're going to run on any of those cores. Okay. So by default, when you write your program, when you write your Ruby program, it's running on a single core, and then you have to start multiple threads, and that gets to run on all the cores, right? So Rails saying that it's thread safe meant that now I can get my Rails application and put it in a machine with 4 cores, and Rails is going to work. Right,
now it'll use those additional cores.
It's going. That's the thing. No, that's the thing. Like thread safe is a very funny word. And to me, it's like it's almost a pointless word, because all it says that now you can run that thing using threads, and it's not going to blow up. It's not going to crash.
It's not going to break because there's multiple cores.
Which is like the lowest possible guarantee that you can give in software, right? Like, imagine if you are like your developer shop, and then somebody's like, "Hey, can you build me this application?" They're like, "Yeah, I can." And then somebody says, "Okay, what this application is going to have? Is it going to be fast?" And then they're like, "No, it's not going to crash." And they're like, "Well, is it going to have a good user experience?" They're like, "I can't say that, but it's not going to crash."
Right?
Like, it's the weakest guarantee that you can give, to the point that when Rails first did that, what they did is that they put a lock around your application, which means it's not going to crash, but only 1 core could access your application at the time. So it literally meant that it's not going to crash, right? Which, of course, we knew, like, I'm not saying like we did that and they were like, hey, happy. It's like we knew there was work ahead. And with time, it progressed. I was part of the Rails team.
So it's a Band-Aid solution.
Yeah, it was the first step, right? Like you say, let's make everything safe. And now we progressively try to figure out how to improve things, right? And it's a long work, because it was not only necessarily like a Rails issue, but, like Ruby still has like the global interpreter lock that is going to lock small operations unless you're using rectors. So it's like it does require a very high amount of work to solve those things, and it's still being worked on in this case. So, and then with time, like we started improving it, right, to make like the lock not to be your whole app, to be a little bit more granular. And sometimes we would get bug reports. So this is the bug report that changed my life. Somebody did a bug report that was like this. They were enabling their application to run in the thread safe mode, so they could use threads. And the bug report was, when we have a spike in production, so a lot of users coming in, and then auto-scaling kicks in. So we are starting new machines.
Yeah.
Those machines fail to boot. That was the bug report, right? So So for me, like when I look at the bug report, like I was like, okay, I know what is happening. So what is happening is that when we are running in the thread safe mode and there's a new machine up, because they're having a spike in production when the new machine comes up, there is a lot of requests coming in at the same time. And then there is some code in Rails that is, because Rails initialize a lot of things like lazily. So like your templates cache is going to be lazy, or like all those active record method definitions, they are going to be lazy. So there was something in that code that was not safe. So the bug was there, right? It's like it's part of the Rails initialization that is not safe, and that is kicks in only when you have a lot of people accessing a newly booted app at the same time, which is going to happen in this scenario, right? But like, okay, how do you find the bug? We had a extract case, right? But if I fix it, how do I guarantee that I actually fixed it? And how do I guarantee that we're not going to have regressions? Those things, they are very hard to test for, right? So that was the thing that was like, well, if everybody is telling me that concurrency is going to be the future, like quad core machines, and today you can have machines with like 64 cores and so on. If that's going to be the future, I feel like I'm missing something. Like there has to be a solution to this problem. So I didn't start with the goal, like I want to create a programming language, right? Like most people, when they have a problem, their answer is not, I will create a programming language.
Let's create a new language.
Yeah.
I believe that's how JavaScript started, but that's another story.
Yeah. So for me, I was like, okay, I just wanted to learn. I was like, somebody probably solved this problem, right? Yeah. And there were a lot, like if you look at the programming languages that were coming up at the time, like Go, Clojure, they all had like this focus on concurrency, like, oh, we are good for concurrency. So, okay, I want to learn. I want to see what they are doing, right? In this journey, I say there were two things that change how I think about software development. And the first one was finding, at the time it was like functional programming, but it's not a characteristic of functional programming. It's really about immutability. Because if you think about it, like the reason why we run into these issues in Ruby and the majority of other languages is because, so you have an array, so you have a data structure, it can be any data structure that is in memory, right? So you have the single place in memory. And what happens if you have two cores trying to change the single place in memory?
Right. Okay. Right? I got it.
They are going to race each other. They are going, and if something, if they can actually do it at the same time, right, you can corrupt memory. So that's why we put the lock around those things to ensure that only one of them can change it.
One at a time can access. Yeah.
Yeah. But the whole idea of immutability is, well, what if we don't mutate data structures? What if I have an array, and if I want remove an element from that array, I give you a new array. I don't change things in memory. And of course, like there are ways we can represent those data structures. We're not always copying everything. There are ways we can represent them so they can share a lot of data and not make it that expensive, right? But I was like, this is beautiful because it actually solves the problem. Like it removes the problem. It's not like we have a problem and then we have a solution and now we have the problem and the solution coexisting. No, it removes the problem. The problem, poof, is gone. All the things, a bunch of the issues that we were having with concurrency, it's completely gone because I'm no longer like changing things in memory. I was like, this is perfect. This is where I want to be, right? And then there are, as I was saying, there are like a lot of languages that focus on this concurrency aspect, on how to do concurrency that were coming at the time, right? But when I was, and then I was learning all those different languages, but then I found Erlang. And the beautiful thing about Erlang is this, like, so again, like this is almost 20 years ago. This is like 15 years ago, 2009. Okay, that I was looking at this, 2009, 2010. Everybody was talking about concurrency. So why we're talking about concurrency? Why does it matter, right? Because, well, if I write a software today and I want that software to run fast, it needs to use all the cores on my machine, right? So for example, if I have a machine with 4 cores, my test suite's taking long and I'm using only 1 core, it's like, it could potentially run 4 times faster, right? So we want our software to run fast in our machines in production. We want it to be able to use all the resources efficiently. So that's the goal. We want to use resources efficiently. And that's going to lead to better user experiences, better developer experiences. That's the goal. So that's why I want concurrency, right? But imagine that you write your application, right? Or your software, whatever, and you wrote it to use concurrency and use all the resources efficiently. But one machine is not enough to deal with everything that you are building, right? So if you're building a web app, by definition, you're using two machines, right? And because you want, if one goes down, you don't want
you know what I mean, like a server and a client, or
yes, a server, right? Yeah. So if you're running a web server, right? If you have a web app that's running a web server, you want to, usually you're not deploying only one, you are deploying two. So if something goes wrong, for some redundancy. So if you think of so if you think about it, like, well, concurrency is going to help me solve with one machine, but sometimes for performance reasons, I may need more than one machine. Sometimes for redundancy issues, I may need more than one machine. So how I'm going to solve the next problem? How do I get the software that was made to run on a single machine and make it run on multiple machines? So in other words, how do I make the software distributed? And so when I was looking at all those languages, Erlang was the only one. And still today, there are other languages today, but Erlang was the only one being used industrially at scale that actually solved the next question, which is like, well, we are going to make it easy for you to write distributed software. So for me, I was like, the beautiful part is that the same abstraction that you use to write concurrent software in Erlang is the same abstraction that you use for distribution. So it's not like I had to learn two different things. I would learn
it wasn't a whole learning curve.
Yes, and solve both problems, right? And then for me, that I was like, look, for me, like everybody, and again, like 15 years ago, and it's mostly true today, everybody was talking about concurrency, but Erlang was like, oh, I solved that. And by the way, I also solved the next problem. And not only that, I solved that like 30 years ago. So for me, it was like, immediately, I was like, okay, that's the thing. And that's why I was saying, like, well, if you think about like the software that we write today, push and pull, right? What you have is that we need to push information. Like, imagine that you're building your web app, you deploy like web servers, and then you have a user connected on this machine from their phone, and then on another machine, the user connected through like the browser, right? So you have two machines. One user is connected here. The other is connected in another place. And you need to send information from one to the other, right? Well, like, if the machines can talk to each other, then it's problem solved. And that's exactly what Elixir does. That's why building this real-time collaborative software is so straightforward, because it just works. It's literally part of the language, part of the runtime. Almost any other ecosystem requires you to bring something like Redis or a message queue or some additional tool for you to figure out all. Yes, right? Yeah. And then there are problems. Like, so we have a web framework called Phoenix. So there's one problem which is like deceptively hard, which is presence or multi-party, which is, imagine that you are building, I'm going to use a chat app as an example because that's like very easy for people to imagine, right? Mm-hmm. But imagine that you want to show everybody who is in the room right now. That's actually like, it's a distributed system problem. It's a deceptively hard problem. And like Phoenix, the Phoenix web framework is the only web framework that comes with a solution out of the box for that. And it's like, it's a solution, it just works. It's not like, install this.
You have to do this.
Right? Yeah, it just works. You just deploy, connect the machines, and it just works. It's telling you in real time. Right? And that's why we have like Discord, for example. It's a great example because Discord, they use Elixir to coordinate their chat stuff. So anyway, long story short, it always started like when I started looking at it, it was like for concurrency. But in that journey, I learned about things like immutability and like writing distributed software that was like, look, this is going to be it. There's a word. It's like it's the best return of investment that you can potentially think about, like learning a technology, because you're going to learn that collection of abstractions, and it's going to give you so much power, so much expressiveness that then you can go and do whatever you want.
You know it inside out. Yeah.
So, and then the more I used Erlang, I felt like, oh, there are those things I would like to improve. And I was like, well, why don't I try to create my own programming language? And
was it of course, at the start, was it like, I'll just do this as a side project, as a hobby project?
Yes.
Or were you serious and like, no, I'm actually going to create something amazing here?
No. At the beginning, like the first prototype sucked, right? Because also like I don't come from a computer science background, so like my first prototype was like an object-oriented language, for example, like trying to run inside the Erlang virtual machine, because whenever I felt that Erlang was missing something as a language, my instinct was like, well, I came from Ruby, so I guess it's objects that it's missing.
Yeah.
Or I guess it is like this particular Ruby feature. And with time, so that's why I built the prototype. So I like to say it's like I was kind of like trying to assemble like this. I don't know, like it was a puzzle, and I was putting the puzzles in the wrong. Like I may have had the right pieces, but trying to put them in the wrong places. So the prototype what really helped me, this initial prototype, was to be like, okay, what are the things for me to try to boil down the things that I was missing? So later on, I learned that one of the things that I was missing, that we do a lot in Ruby, for example, we have duck typing, right? Which we can pass objects around, and we say, well, as long as the object responds to these methods, you can pass it around, right? And then at the time, I was like, well, I can do that because of objects. But later I realized that no, like that thing is called polymorphism, and there are many different ways you can implement that thing without having objects. And Go, for example, is another programming language that, they do not have objects, but they have polymorphism and closure as well. So when I built a prototype, I was able to figure out like, okay, this is what I need. I was able to figure out the problems. So then I could work on figuring out the solutions, right? So I was able to decouple the problem from the solution. And then after that, after I was like, and so I figured that out, and then I spent almost a year just learning more programming languages, because I had the idea to even before I started with Erlang, I was in the period where I was learning a bunch of different programming languages, and then I looked at Erlang and I was like, this is the deal. That's what I want to use. Then I learned Erlang, built the prototype. It was bad, and I spent like probably like almost a whole other year just thinking about like learning more languages, but now approaching more like how they are like before I was learning how to use them, but now I was learning like how they actually work and what are the concepts. And then I was able to come up with a vision of pretty much what Elixir still is today, of what I want that language to be and what I want those features to be. Right. So, for example, something that we have in Ruby and we use a lot is metaprogramming. Right. And my first attempt was to bring Ruby style of metaprogramming into Elixir. And then I realized, which is not really, it's not a good fit for a few different reasons. And then I realized, oh, there are other ways I can do metaprogramming. And I learned that. And then I figured out, okay, those are the pieces that I want. And I think I can actually build a language that, when paired with the Erlang virtual machine, is going to feel interesting and feel empowering and productive. And that's when I thought, like, okay, I can have a shot. I did not know if it was going to be a success, I actually
Yeah.
did not actually put too much thought into
Was
that.
there a moment? Was there a time when you thought, oh, I'm off on the wrong path here. I'm not gonna do this. And like, was there ever a point where you thought of giving up, or you were just like, no, I'm on this path. I'm going to make it.
I don't think there was a point where I thought I would give up. Not because I was like, oh, I feel I'm right, but because I think I was fortunate to get like a reasonable good amount of users and interest relatively soon.
So you got that feedback loop happening.
Yes, exactly.
Yeah.
So around, I'm not going to remember the dates anymore, but I would say that I made a decision of like, okay, I think, and that's when I presented to the company. So this was about 2012. That like, look, I think we can try to build this, like try to build this programming language. And one of the things that I put, and as I told you, like I knew that this could be like a multi-year project. So I was not worried about adoption. I did not want to, not that I was not worried.
It wasn't an immediate, but must be successful today.
It was not like a KPI, let's say. I would not measure the success by adoption at that stage. Because I didn't want to put myself in the situation where like, oh, if I add this feature, maybe we'll get more adoption, which I don't think it would be the right way to think about it at that stage. I wanted to build a language that I felt would be the correct language to build, right? With the features that I feel it's correct.
That solved the problems that you knew existed.
Yes, and that leads to adoption, great. But if that's not the thing that people want, then I would probably close down the project, then build something that I don't agree. So that was my mindset. And
conversely, because I asked you, was there a point of failure? Was there a point where you went, I've done it? I mean, I know it's never done, but there's a point where you went, I've solved this. Now I can start creating something more. Like, was it your first client, or was it after that?
No, so I think there were like a couple moments like that. So, so one was, I think within 1 or 2 weeks, we had 2 Elixir books announced, like different authors. So Dave Thomas, which we know and love in the Ruby community, and Simon St. Laurent, they both announced they are writing a book on Elixir. So that was a big moment. Like, like they are now...
Because then it's more than just you.
Yes. There are now like enough people investing on it. Like they are, putting their money on it as well. And that was and I knew that would have a huge impact on adoption. And then we have the first conference organized by Jim Freeze, which was 2014, I believe. So within 2 years, like in my pitch, I was telling people like we can work on this for 3-5 years, right? And then within the 2 years, I was already getting that kind of feedback that was really helpful. So I did not went into the despair of like, oh, maybe this is not going to work out and have to deal with that particular set of feelings. But later on, as the community starts to grow, like as I was saying, like I think most of my goal is I want a decentralized community. I want people, because I knew that I would focus on making Elixir great for the web, because that's where I came from. I came from the Rails community, and I knew that I would like naturally attract people from that community.
Of course.
Chris McCord, the creator of Phoenix, he came from the Rails community as well. But I knew, so Erlang was used to build like distributed systems and databases, right? So I was like, I knew that. So if Erlang is good for that, Elixir is going to be good for that too. So I wanted to allow people who have the right ideas to come and build those ideas as well. And maybe there are a bunch of things that I don't know, right? And we should allow them to basically get Elixir and mold Elixir into the domain they're working on. So another great example that was like, oh, this is amazing, and this is getting a life of its own, is so there's a project called Nerves, which is about Elixir for embedded software, right? And the idea is exactly like, well, so one of the things we didn't talk about it, but one of the things that we also inherited from Erlang is how do you build robust and fault tolerant software? Because again, like if you're building like a telephone switch, that's basic infrastructure, right? That's what Ericsson is building. That thing cannot fail. It needs to have like 9 nines of reliability. Like it needs to be really solid. Right. So they thought about all those things. Elixir inherited them. So the nerd folks, they were like, well, building embedded software is actually really hard because you have all those different components like Wi-Fi and Bluetooth that sometimes the hardware fails. So how you're going to reason about failures and make those things like fault tolerant? And then they're like, oh, Erlang is going to be great for that. And Elixir has a really great tooling. So we can build a framework. So we have a framework for embedded software. And today we have things like Mainbrain, which is about using Elixir for multimedia processing. You can use Elixir to write machine learning and neural networks models that run on the GPU. So every time like we're like, oh, we got Elixir, especially when it's somebody that was not me, they got Elixir and they use it to run on a completely separate domain, something that I know nothing about, right?
Yeah.
For me, that was like, I was like, okay, that's working, right? It's like, it's things people building on top of it. And I am not involved, which going back
These
to the
surprising
idea.
ways people are using your baby, so to speak.
Yes. And going back to the idea of decentralization, that's what I wanted, right? I wanted people to be able to do, right? To build all those things. And I don't ever need to be consulted about it.
No,
I just go ahead and make it amazing. And it's meant to be like a characteristic of the language as well, right? It's like, you know, like the language should be extensible, that people can do all those sorts of things and not have to open up an issue to run, make the language.
Some feature they just don't have and need. I have a question, Jose, that I've always wanted to ask somebody in your position, someone who's developed a language. You know, we think about Mats and we go, you know, Mats is nice and we're nice. But to some degree, I feel like that's baked into Ruby as well. Like Ruby is a nice language insofar as it's readable and understandable, you know, like, and then we think about DHH and we go, okay, you know, he's opinionated, but then Rails is highly opinionated. Do you feel like you've baked some part of your personality into your language? Or is this something we just impress upon it afterwards that didn't actually occur?
I think there's definitely, it's hard to say what part is a personality and what part is something that you want to. There's a difference between being a person, it be a personality, and it be something that I wanted to impress on it myself, right? So basically the question is like, those things when they happen, are they intrinsic or are they extrinsic, right? Like, you know, like like DHH is opinionated, as you said, but he could have made a framework that is not opinionated, but I assume that he chose
I feel
because
like he probably couldn't have.
Right. So there's this question. There's this exactly. So I that's exactly the question. So for me, I think if there was something that I wanted to have into the language, and it was something that was very clear for me at the beginning, which is for the language to be welcoming. I know. So if we think about the things that make Elixir special, right? It's immutability, which today is quite more widespread, but it's concurrencies. Like the things we have been talking about, like thinking about fault-tolerant software, thinking about distribution, all those things, you're not going to really learn those things when you're learning JavaScript and we're learning Python. So asking you to learn Elixir is, I think the payoff is fantastic. As I said, it's possibly like a great return over investment, right? Is asking you to learn about a bunch of new things. And I think to a fantastic effect, even if you later say, I'm not going to use Elixir, right? You're going to learn a lot, think about problems differently. But it is a learning, it is something that we're asking, right? Look, you have to think differently about things. So we need to have a good experience. Like, we need to be welcoming, right? Like, there should be no things like some other communities that were part of other communities, like, like read the manual, right? Like all those, like, all those things, like, it should not, like, questions should be welcome. There are no such things as stupid questions. We should be welcome to new ideas and new approaches, because we are going to have people coming with all different perspectives, right? And we cannot really prescribe, like, it would be really bad if we prescribe that, oh, we can teach this for you if you have that particular perspective, right? So we need to be very open-minded about all those things, how people will learn their journeys, and how we can make sure that as smooth as possible. Because for me, there is something that is like, I think the thing that I like to do the most, like, I've been programming for almost 20 years. I think my first program was 2004. It was not serious, but yeah, so 20 years. And for me, like, the most fun part of programming is always the learning. Every time there is like something new for me to learn or to explore.
I agree with you completely. Yeah.
Right? Like, that's the best part.
Yeah. Doing something you've never done before.
Yes.
Yeah.
Or it's like opening up a new world, right? And it's like, oh my God, there are so many things. So that's the thing that I really focused on. It's like, well, I want to make, like, if you want to learn, you're going to learn, right? And you're going to learn great things, and hopefully it will feel exciting, and it will make your mind race about all the different things you can now do and think about.
Yeah, absolutely. Absolutely. And that feeling of never really being done on a project, because there's always some new idea. Oh, let's just try this and see what happens.
Yeah.
Or, some wild idea. Well, I don't know how to do that, but let's figure it out.
Yep.
That's all part of it. What's next for you? Like, where do you go now? You've developed an entire programming language. I mean, obviously there's more development to do on that, but what's next for you?
Yeah, so there are a couple of interesting things. Is like, because, so I was talking about the decentralization. So I like to say that Elixir was built to be extensible. And about, I think already 6 years ago, I told in a presentation that Elixir is kind of done, in the sense that, look, if you want to do something, you can just get the language and do it. You don't have to change the language, to the point that, like, when we made Elixir compile and run on the GPU, so we created like this library called numeric Elixir. It needed one commit to Elixir to make that happen, right? It was a pull request that added a feature that was missing, and they're like, okay, we are good. We have everything that we need.
Right.
So, and even before that, so my point was like, look, the focus should be in the ecosystem, in the community. That's where we are going to see the language grow. And for quite some time, most of my time was actually not spent on Elixir. It was spent on community projects like Phoenix, the web framework. I am a part of the team there as well. So I was actually working on all sorts of community projects. But there was also, which also happened in the Ruby community, there was also this question about, hey, what about static typing? Can Elixir be statically typed? And I built a prototype as well for that, but it did not work properly. And so it was always an open question until about, 5 years ago. 2 students from Uruguay, they did their masters on adding gradual typing to Elixir. And then that eventually, and then I asked them, like, hey, maybe you want to work on this and make a project? They're like, nope, we are out of university, never coming back. But that eventually put me in touch. So if when I read the paper, there are the citations, and like, probably half or more than half of the citations led to a researcher called Giuseppe Castanha. And I ended up reaching out to him, and we started talking about, can we add typing to Elixir? Right. But now I have a very known and well-respected researcher on my side of the ring against types. Right.
Yeah.
And so that has been kind of my main focus in Elixir for the last 3-4 years. We publish papers, which is something that, as somebody, when I said I was learning a lot of Elixir, I was also reading a lot of papers. So I was used to consume a lot of academic material. So for me, being able to publish a paper, get actual awards on the paper, it was really fascinating. And so that's what I have been doing, and it has been going for 3-4 years. And the work that we have been doing has been really calm. Every step that we take, it's intentional. So Elixir right now, when you compile Elixir program, there is actually a type checker running, but you don't define a type signature anywhere. So what we are doing is that we are looking at your program and trying to find things that we are sure are bugs or errors. So we are trying to find those things and surface them as type error for you without you having to change the program at all. So I want to find bugs for free. You shouldn't have to put any effort. And that's what we have been working on. And it has been a lot of work. It literally needs new research. We have things in Elixir, because that's the thing that I think a lot of people, they don't realize about types, is that the type system, all type system, restricts which kind of programs that you can write. So all languages that are statically typed, sometimes you write the program and then program does not compile. This makes total sense, but it's the type is well, I don't understand it, so I'm not going to allow that to run. And of course, if you have an existing language and then you put a type system that is going to be all the time, hey, you can't write that anymore. It's well, is that really then the same language, or is that a different language? If it's really forcing you to write all those things differently. And of course, I expect types to change a little bit how people think about the software as well. That is an expected property. But there is an amount, right? It's definitely a balancing game. So, and if you want to type a language like Elixir, there is not theory, and it's not specific to Elixir, it's just dynamic languages in general. There is no type system theory that is going to type everything that you can do, right? So, literally, we are researching and developing new theory with mathematical proofs and so on for us to do that. So a lot of my work is I'm not doing the research because there are mathematical proofs and it's above my pay grade. Sometimes I can do a tiny proof. Yeah.
Yeah.
But it's funny because then we have papers published, and then there are sections in the paper that I do not actually understand. If you ask me to explain it,
but that's fine. That's why you collaborate. That's why you have people with you.
Yeah. So
tell me about Tidewave.
Right. So working a lot on that side of Elixir.
Yes.
But lately with AI, which I know there are a bunch of mixed feelings about it, right? But going back to this topic of learning and exploration, right? I think one of the things about AI, especially for me who has been working on developer tooling for quite some time, languages, frameworks, tools, is that I think it throws enough of a wrench into how we think about certain problems. For us, can I rethink this problem and how we do it?
Right? Maybe there's a better way to approach this, that sort of question.
Yes. Or even things if you say, so the thing that makes AI have a lot of mixed feelings, because we have these claims where people are saying hey, AI made me 10 times more productive. And then I'm that's a lie. Because first, the thing that we do the whole day is not only write code. And if you're using AI to write code, it may help you write that code faster, but it's not going to make you 10 times faster, right? Because it will require parallelizing almost everything.
Look, I can tell you, I've spoken to a lot of very senior developers this year and asked that exact question, CTOs, people who run large groups of developers and consulting agencies. And the consensus amongst all of those senior developers is an improvement of about 20 to 30%. That seems to be pretty universal at this point.
Yes. And I think that's exactly the point. Like, people are coming with those claims. But if you say, look, I am 20%, 30% more productive, that's already such a big impact.
It's massive.
In general. Right?
Yeah.
If you go like to any CTO and say like, hey, I have something that is going to make your team 20, 30% more productive, they'll be like, here's my money. Immediately, we don't have to claim like these absurd things, like 20, like 2.
No, because they don't bear
times.
out. They're not factual.
Right. Yeah. So, but even if you say like 20, 30%, it's enough for you. Well, maybe I can have a smaller team now that reduces the amount of communication points and you can be more productive. But it also means that, hey, now we need maybe more people doing QA because we are going to produce more software. Right. Because if you decide to maintain the team size, and maybe that is going to affect the product owner as well, because the product velocity is going to increase, right? So it already makes you like, well, if that's actually true, so if 20, 30% is what we are going to come out at the end, like, imagine that at the end of next year, we are still settled on 20 and 30%. I still think it changes things enough for you to rethink things, right? So our idea, and then I started using AI. There is this thing, and there's like this big question. So like there's this big race right now. It's like, hey, are humans going to be in the loop? Or are you just going to go to like a chat box, say, hey, implement this feature, and then the agent goes, get your repository, clone it, develop the feature? Like, how much are we going to be in the loop of the development process, right? And I don't see that other thing happening yet. Maybe it will happen. That's what everybody is
it could be in the future.
On.
It could be, but it's definitely not in the short term.
Yes. So I'm like, look, I want to build the tool. So like, if I'm going to assume that the human is going to be in the loop, I want to build a tool where I am going to be in the loop and I'm going to enjoy using that tool and I'm going to feel productive, right? Because if you're building a web app and you're using a coding agent, so that's what I was doing. My flow would usually be, I would go to the editor and say, hey, build this feature. And then the agent would go build the feature. It's like, hey, it's done. And then I would open up the feature in the browser and there was an exception page. And then I was like, oh, exception page. Then I had like to copy the exception, paste that to the coding agent. And the coding agent, oh, I see the error. I'm going to fix it. And then the agent would be like, and then I would look at the code, and then the agent would be using like some method or some class or something that is not supposed to. And they're like, oh, you should use this other thing. And then the agent's like, oh, I don't know how to use this other thing. And they're like, oh, God damn it. And then I would have to go copy the documentation, paste to the agent. So I felt that I was in the loop, but doing unnecessary thing. I was doing like very mechanical, very boring.
You sound like a project manager running a junior developer.
Right. It was absolutely not fun. And I was like, look, what I want to do is that I want to have, and coming from the background of building tooling and frameworks, I could see the gap between the agent knowledge and what is available in the language or in the framework. So what if we can close that gap? And that's what Tidewave, which is the product that I'm working on. So that's the other half of my professional life.
That's what you're doing from 3 till 5 a.m.
Yes. Yes. It's exactly, so it's a coding agent that runs in the browser, but we deeply integrate it with the web framework that you're using. So because all the coding agents, they're like, oh, we work with all the languages and we work with all the frameworks. But if you say that you work with all the languages, with all the frameworks, you basically, it also like, we don't work with none. So what we do is that we go like for each framework and we integrate, we make the agent be able to understand everything from the UI to the database. And that cuts a lot of that boring back and forth. So for example, if you want to implement a feature, imagine that a very silly feature. Imagine that you want, for example, you have a page with some table and you want to add an export to CSV button. Usually what you do is that you open up the page in your browser and they're like, oh, okay, I want to add a button here. So there's a drop down, for example. Now you have to go to your editor, find where that drop down is in the source code and tell the agent, hey, I want you to add a new option here, right? So you have to look at the screen, map that to the source code, write the prompt. With Tidewave, you just click the thing. And when you click the thing, we know that you selected the drop-down, but we also tell the agent exactly where that drop-down is defined because we instrumented your web framework. We know this.
So it's not just a UI tool.
No, it's like it understands everything. And then we understand how things are rendered, where things are on the page, why they are there, right? And we also like integrate with the database by default. So the agent goes, start building the feature because we tell exactly where it is. So it knows what to change. So it starts changing it. If there is an error page, we identify the error pages, automatically feed that to the agent. So the agent can fix it. Yeah. And then later when the feature is done, very often the agent is going to use the browser to test that the feature also works because Tidewave runs in the browser. But many times it's also going to check in the database. So imagine that you're building a feature that has a form, or you want to change how a form behaves. Like the agent changes the feature, then fills in the form and does a query to the database to make sure that the data is in the correct place. So basically we are giving a lot of more agency to the agent, right? And the benefit is not like, oh, it's like I'm phasing me out. It's just that then I can focus on the things that matter, right? I can focus on like, like how I'm going, if I have a large feature, how I'm going to break that large feature down into steps so I'm not doing boring work. That's, like if agents become the future and my job is getting things from a browser to the agent or reading the documentation for the agent or checking things in the database for the agent,
surely
I would be miserable.
Things. Yeah. Uh-huh. Yeah. Yep. Completely agree.
And the end result is that, like there is a tool now that I really enjoy and I really feel that you said like the 20-30%. Yes, I feel I am getting the 20-30% out of the tool. Yeah.
Yeah. Yeah. Yeah. I love that approach. I'm interested in the edge cases of where the AI tools can't resolve a problem. To discover it, I started working out, I started on electronics, not because I'm an expert on electronics, but because it's hands-on. You have to have your hands on it. Like the computer can write some code that'll send it to a chip, but you still have to, it doesn't know if you've got a solder wrong. It just knows the current's not flowing, Yeah.
Yeah.
So anyway, yeah.
No, but I think my mindset is exactly that, in the point that we are putting the agents like in our terminals and in our editors. But I think for the agents, for them to really work, they really need to do the mapping between the code and the thing that is actually built, right? That's why we put it in the browser. The reason we put it in the browser is because we know it can change the code. That's
sure, that's
all coding agents do that, right? But what if we can make it understand and interact with what it actually builds and do the mapping? It's not like, oh, it understands the building, it understands the code. You need to understand the changes that it makes.
Right.
To
what
the
is
code,
the function that produces that?
How that affects the end result. Because that's something that we also do. Like that's development is being able to do that as well as we do in our day-to-day. Right. And I don't think it's web related. Right? I think it kind of applies like to everything. Electronics, of course, there is going to be, unless you have a robotic arm that the agent can coordinate to do the soldering, which is a way bigger problem. But there are parts of like, for example, imagine, so going back to nerves, right? I would start thinking, the agent is not going to be able to interact with the device, but we should allow the agent to investigate or manipulate Wi-Fi functionality, Bluetooth, like all the things that you would do as a developer, the agent should have a mechanism of controlling them and, and investigate them as well. And then, of course, like things as an accelerometer or a thermostat, those become harder for you to, but there are things in that scope. And that goes like for mobile, right? Like you're building something for a mobile app, have the agent be able to actually interact with the mobile app, right? Oh, you're building a game, put the agent inside the game engine so it can actually
right, so it can see what happens when
yes,
yeah.
So that's the mindset.
Yeah, I get it. I love that viewpoint. I've got a long list of questions I haven't asked, and but I think we might wrap for today, and maybe I'll ask them another time. But I do want to ask. I've got 2 more questions. I've got 2 more questions, short ones. First of all, are you going to be in any events, conferences? Are you doing any sessions coming up soon that people can hear you and meet you and talk more to you?
So I'm usually at the Elixir conferences. So we have Elixir conference in Europe and United States. And I know for next year, I'm going to be at RubyConf in Austria.
Great.
So if anybody's coming, it will be great to chat.
Yeah, awesome. Last question, I always ask this one. Is there anything specifically you wanted to tell me or tell the listeners that I didn't ask you or maybe prevented you from saying?
No, I think we are good. I speak a lot, and you gave me plenty of.
I love talking.
To speak, so I got. Hopefully, I got the message across. Yeah.
I love talking. Like it's the reason I do these podcasts, because I like listening to the stories. I like hearing and understanding where people came from and where they're at now. And whenever I'm at conferences, I expect. A lot of people are like this too, but I start talking to someone and then miss all the sessions because I'm in the I'm doing the corridor track,
Yep.
I just can't stop talking to people. Well, thank you very much for joining me today. And I really do appreciate it. We will talk again soon. Thank you.
Yeah. Thanks for having me.
Bye. Technology for Humans is hosted by me, Errol Schmidt, and produced by Reinteractive, a Ruby on Rails development agency working with teams who care about building software that lasts. If you enjoyed this conversation, please subscribe wherever you get your podcasts and join us as we explore how technology is built by humans for humans.